All right, so first disclaimer on this part. I am not a car person. I get into a vehicle, I turn the key, and it goes, and all is well with the world. I'm not a mechanic. However, uh, after starting to teach this class, I've learned more about how like piston and cylinders work. So I'm going to share a little bit about that with you. Again, I'm not a car person, but I'm guessing there's lots of you who also aren't. So this information should be hopefully interesting to you. All right, so the engine that we're going to talk about is called a four-stroke engine, and we're going to look in particular at the piston and cylinder. So, cylinder, piston. These came from a Harley Davidson. I'm hoping you can see them good. These are used, and they do a nice job of demonstrating this. So you can see it's a cylinder, there's a hole through it. The piston is going to go inside. Now, in all actuality, this is going to come up from the bottom, but for ease of showing you, I'm going to do it from the top. Now, this fits in pretty tight, and then it'll slide up and down. Again, it starts from the bottom. This is hooked to an arm that's hooked to a crankshaft. And as this goes up and down, it causes that crank to turn, and the turning motion is going to provide the power. Again, I'm not a car person. This is very simplistic terms. But as it goes up and down and how it injects the gasoline into there, it talks about a four-stroke engine. So we'll talk about those four strokes. Again, fits inside. Again, it comes from the bottom, not from the top. And it fits really tight in there. It's really tight in there. You probably can't even see any light around that. Okay, so I'm going to put this down. The first stroke is called an intake. So the piston's going to move down, and it's going to allow fuel to come in into that area. So cars and motorcycles are flipped from one another. So the gasoline gets pulled in. The next thing that's going to happen is that the piston is going to move up, and it's going to compress the gas. The reason that we compress the gas is that so that it provides more power when we have that explosion that's going to occur. Now, when it's completely compressed, and you can compress it to different ratios, as we're going to find out, we have what's called the power stroke. So the spark plug gives sparks. It gives a little spark, and it causes that gasoline to explode. Ideally, we want one nice explosion on the surface. That's going to cause the piston to move downward very, very quickly. Well, now we have all these spent gases in there, and so the piston's going to move back up, and it's going to force all of that exhaust air out. Then it starts over again. Then the gasoline is fed in. We compress the gasoline. We have a spark, causes the explosion. It's forced downward, and then we're going to get rid of the exhaust. Now, so there's intake, compression, power, and exhaust. Those are our four strokes. Here's another way that you can remember it. Remember, you're a mature college student. We could also talk about suck, squeeze, there's two E's in there, bang and blow. So it sucks the gas in, it squeezes it to a smaller area, we have an explosion, and we blow out all of the exhaust. However, helps you remember. So I told you in the compression stroke that the piston is going to compress that gasoline into a smaller area. The smaller the area or the volume that it compresses to, the more powerful the power stroke can be. But it gets a little bit tricky. So you can change how much compression there's going to be. That's called the compression ratio. The more compression, the more power. But the more compression, the more likely it is you're going to see knocking occur. Now, knocking is whenever you have a pinging or a knocking sound that occurs when air-fuel mixture combust erratically. This can cause a loss of power. It can cause inefficient fuel use, and it can also pit or fracture the top of your piston. That's really, really bad. So I had a truck that I bought right after I got out of college. We had wrecked my old one, so I had to buy a new one. And it had a manufacturer defect that caused a lot of knocking issues. So you'd be driving along, you would hit the gas, and all of a sudden that engine would start knocking. And it's like you hit the gas and the engine almost died. It was so bad. There were days I was just hoping and praying I would make it home. Luckily, after the third dealer looked at it, we finally got that problem fixed. But that compression ratio can also lead to some of those issues. You don't want to have too high of a compression ratio. Down at the bottom of this slide, we have two different pictures that are looking at that explosion that's going to occur from the spark plug. Now, this is actually fireworks, but it gives you the right idea. So what we want to have happen is that right at the top of that, the start of the power stroke, so we have all of that gas compressed as much as possible. We want to have one single nice spark that causes the explosion. All of the gas combust at the same time, and it forces that piston very quickly the other way. What can happen though is you might have pre-ignition where the piston's not quite to the top and we have that spark. That spark is going to try to make that piston go down, but it has to go a little bit higher before it can actually start that stroke. That's one issue that might occur, pre-ignition. The other one is whenever you have an erratic sparks that occur or erratic explosions that occur. So instead of one nice big explosion, you have a whole bunch of little ones, and that's going to cause issues with how that engine runs. So again, not a car person, but hopefully that makes you a little more aware of what's occurring. Even in something simple like running a car, it's not as simple as we want to make it.